China's mega machines just broke every rule of physics. Experts are stunned. There was a time when the word monument brought to mind the pyramids, or at least the Hoover Dam. But forget all that. In China, people no longer build projects, they launch campaigns. And their weapons are not missiles, but steel monsters that eat mountains, swallow rivers, and melt the patience of Western engineers. By the end of 2024, China's operating high-speed rail network had reached about 29,200 to 29,800 miles, the largest in the world, proving that its infrastructure campaign had evolved into a resilient industrial ecosystem. In California, the high-speed rail line has dragged on for 16 years, still stuck in meetings. During that same time, China has completed more than 24,900 miles of tracks, slicing through mountains, crossing rivers, and weaving beneath massive cities. From above, the country looks as if it's piecing the planet together with giant Lego blocks, except each piece weighs hundreds of tons and runs on diesel engines. While the West spreads its resources across countless small research institutes, China has chosen a different path, concentrating all intellect, manpower, and funding on a single goal, building faster than anyone else. The result? One side produces volumes of academic papers hundreds of pages long. The other produces young engineers who operate colossal tunnel boring machines around the clock on 3 continuous shifts a day. This is no longer traditional industrialization. It's hyper-industrialization, where machines become the soul of the nation. In Hangzhou, some machines can drill 6.2 miles of tunnel in a single day, while in New York, a short 984 feet section can still take 8 months to finish. And when machines became the symbol of national power, the Chinese people themselves gradually turned into part of the machine, precise, relentless, and almost never switched off. In the West, engineers are the ones sipping lattes and talking about work-life balance. In China, engineers are the ones pulling night shifts, downing energy drinks, and discussing torque ratios. Picture this. In the dead of night at a tunnel construction site in Sichuan province, a tunnel boring machine as long as a 20-story building growls like a gigantic metal beast. Welding sparks flash, the ground trembles softly. As one shift ends, the next one lines up. There is no off the clock, only a change of operators. No one says good night. They say, watch the pressure in the cutting chamber. Each year, 1.5 million engineers graduate, more than the population of some European nations. Every time the West holds a conference on how to cultivate talent, another wave of fresh Chinese graduates is already donning hard hats and descending underground to operate machines worth hundreds of millions of dollars. In the US, engineering students dream of working for NASA. In China, they build the launch sites. In the UK, they write dissertations on the social impact of transport infrastructure. In China, they finish the highway before the dissertation gets approved. While the West debates automation and worries about robots taking human jobs, China sees it differently. There, they don't need robots to replace humans. They turn humans into parts that operate with machine-like precision. From a wider view, the entire nation functions like a vast programmed system. The state acts as the central processor, corporations provide the engines, engineers serve as pistons keeping rhythm, and tens of millions of workers are the gears spinning endlessly, perfectly synchronized. While many countries pause for holidays or weekends, China keeps running, as if the whole nation were working overtime alongside the planet itself. And then, once humans began working like machines, the next step became inevitable. The machines started behaving like humans, intelligent, stubborn, and occasionally defying the laws of physics. Enter the tunnel boring machine, a name that sounds dry and technical, yet its operation is anything but. Imagine a massive block of metal, as long as a 20-story building, laid on its side, its circular head resembling a steel-bladed UFO. When it spins, the sound reverberates like a rhythmic earthquake, each rotation devouring layers of soil and rock ahead. Many describe it as a monster of construction. If Earth were an egg, this would be the spoon capable of scooping out its core. Back in 2000, China couldn't even manufacture a single tunnel boring machine. They had to import them from Germany, Japan, or the US. Each project meant long delays, massive costs, and total dependence on foreign technology. 2 decades later, the balance has flipped. 7 out of 10 tunnel boring machines grinding through the earth worldwide now bear the label Made in China. A reversal so complete that it has left Western engineers wondering when exactly they fell behind. While California has spent billions of dollars and 16 years digging a single high-speed rail tunnel, still unfinished, in China, a single machine can carve out 6.2 miles of tunnel in just 24 hours. One day. Meaning that by the time you finish watching this video, it's already advanced a few hundred meters deeper into the earth. One of the most iconic giants of this new generation is the CRCHI tunnel boring machine, a symbol of the fusion between precision engineering and artificial intelligence. Firstly, we're going to visit the assembly area of the tunnel Bing machines. China has the world's biggest. With a diameter of 49 feet, weighing nearly 4,000 tons, and a power output of 10,000 kilowatts, equal to the combined thrust of 5 Boeing 747 taking off at once, this machine is a true titan of engineering. But what leaves engineers around the world speechless isn't just its raw power, it's the level of automation and its uncanny ability to sense the geology around it. As you can see, this one is an open-type 3 per TBM. It has a diameter of 7.03 meters. Inside its steel body lies a network of thousands of sensors, industrial cameras, ground-penetrating radars, and a real-time data analysis system. The CRCHI tunnel boring machine can read even the faintest vibration in the soil, detecting moisture, pressure, and mineral composition ahead before its cutting head ever makes contact. If it senses weak ground or underground water pockets, the central AI system instantly adjusts the chamber pressure, rotation speed, torque, and slurry balance. Every movement is automated and incredibly precise. The deviation rate is only about 2 to 3 millimeters per kilometer, far below the international standard of 0.4 inches per mile. At the CRCHI headquarters in Changsha, engineers can sit thousands of kilometers away and still monitor and control the machine via a digital twin. This full 3D replica mirrors the TBM's real-time status. Every parameter, from hydraulic oil temperature to rotation speed and body tilt, is updated second by second. If there's any sign of a jam or trajectory error, an early warning system triggers an emergency correction mode, allowing intervention even when the machine is working 197 feet underground. And this technology is no longer confined to China. CRCHI TBMs are now operating in some of the world's toughest projects. The Jakarta-Bandung high-speed rail in Indonesia, where they cut through layers of basalt and soft clay, the Doha Metro in Qatar, enduring desert heat that reaches 122 degrees Fahrenheit, and the Istanbul Metro in Turkey, where one unit completed over 3,937 feet of tunnel in just 20 days, setting a regional record. Beneath the earth, China commands steel Godzillas that chew through mountains and swallow rivers. Above ground, it commands an army of mechanical giants, iron creatures that lift bridges, raise skyscrapers, and lay railways with the precision of a Swiss watch. These are the machines redefining what the world means by construction. The first of these titans is the SLJ 932, better known by its nickname, Iron Monster. It stretches 299 feet long, nearly 329 feet tall, and weighs 580 tons. It can lift a 908-ton concrete beam, the equivalent of 8 high-speed train cars. Unlike traditional cranes that rely on scaffolds and support rigs, the Iron Monster needs no assistance. It drives itself to the site, grips bridge beams with its steel frame, crawls to the edge of cliffs, and places each segment with less than 1 millimeter of error. What stuns Western engineers most is its sideways motion. Equipped with 64 wheels, divided into 16 independent modules, each able to pivot 90 degrees, the Iron Monster can slide sideways like a colossal mechanical crab. When empty, it moves at 4.9 miles per hour. Fully loaded, it still maintains 3.1 miles per hour, astonishing for a 600-ton block of metal. Over its lifetime, a single Iron Monster can assemble 1,000 bridge spans before retiring, the equivalent of decades of tireless service. According to China Railway Construction Corporation, the SLJ 932 has already reached its 4th generation, using aerospace-grade high-strength steel that's 12% lighter yet 20% stronger. The new version also features a hybrid power system, saving 25% of fuel, cutting carbon dioxide emissions by over 30%, and running 72 hours non-stop without refueling. Thanks to these upgrades, the Iron Monster is now exported to India, Indonesia, and Turkey. If the Iron Monster is the giant laborer, then Kunlun is the Dragon King. Designed to lift and place box girders weighing up to 1,000 tons, Kunlun can perform on 30-degree slopes, tight curves, and mountain terrain where even tanks hesitate. Measuring 302 feet long, it's equipped with laser positioning and gravity balance sensors. It doesn't need a flat road, only data. As it moves, each massive wheel adjusts its height independently, stabilizing the load like a robot with a flexible spine. Every lift is guided by a central computer, calculating tilt angles to within 0.1 degrees, ensuring perfect placement in minutes. In 2023, Kunlun was deployed on the Fujian Sea Crossing Expressway Bridge, a 9.3-mile mega-project. Within months, it completed the entire girder installation, while the Golden Gate Bridge, just 1.8 miles long, took 4 years to finish. Then comes the heaviest hitter on Earth, the XCMG 8800, a crawler crane capable of lifting 4,000 tons, enough to hoist an Airbus A380 into the sky. It stands 472 feet tall, weighs over 5,000 tons, and runs on 3 Cummins engines, delivering 1,900 kilowatts of total power. Its structure has 2 parts, a main boom up to 459 feet long, switchable between heavy and light modes, and a mobile counterweight unit weighing 2,900 tons, moving on tracks to balance massive loads. Inside its cabin are air conditioning, shock-proof glass, and even a sofa, because at hundreds of meters high, even engineers deserve comfort. Don't be fooled by its name. The Pump King is no ordinary pump. It's the world's tallest concrete pump, having delivered concrete to 2,037 feet during the Shanghai Tower project, taller than the Eiffel Tower itself. Its 7-jointed arm moves like a human limb, folding, extending, and twisting in tight spaces with 0 vibration or drift. A shock-dampening system cuts vibrations by 50%, saves 10% fuel, and keeps concrete flowing as smoothly as an Italian espresso. The Pump King's AI system can self-diagnose over 150 types of faults, predicting wear, oil loss, or pressure leaks, and alerting engineers remotely through its monitoring network. It can pump 1,059,400 cubic feet of concrete before needing maintenance. In other words, the concrete tires out before the piston does. If concrete is pumped like coffee, railways are laid like instant noodles. That's the job of CYP 500, the most precise track-laying machine in the world. It can install 1.2 miles of track per day, automatically adjusting height, curvature, and alignment with an error margin under 0.079 inches. It works 24/7 through sandstorms or heavy rain. The CYP 500 combines 3 stages in one: laying sleepers, placing steel rails, and fine-tuning pressure and spacing. In 2020, it was deployed on the China-Laos Railway, finishing so fast that Lao engineers joked they must have lost a few kilometers in their sleep. And if the Iron Monster rules the land, then the Yahong Ginyan 2 reigns over the seas. This 6,000-ton semi-submersible vessel can carry entire structures that ordinary ships must disassemble for weeks. The Yahong Ginyan 2 can submerge itself to let cargo slide on board, then rise to lift entire buildings like a magician levitating architecture. Its auto-leveling system of pressure sensors and balance pumps keeps the deck perfectly flat, even with thousands of tons of uneven load. While other ships halt in 9.8 feet waves, this one sails through 19.6-foot swells, steady as if daring Archimedes himself to object. When machines learn to bend the laws of physics, the Chinese learn to bend time, because there, the only thing more important than power is speed. In New York, people debate for 5 years just to approve a bridge. In China, 5 years is enough to build it, take a commemorative photo, and tear it down to build the upgraded version. In 2015, much of the world was still building skyscrapers with Excel sheets, PowerPoint slides, and promises. Meanwhile, China was building with steel, modular systems, and strong black coffee. In the city of Changsha, the company Broad Sustainable Building erected a 50-story tower in just 19 days. Yes, 19 days. Elsewhere, getting a construction permit alone would take 19 months. They completed 3 floors per day, fast enough that if you stood and watched, you'd feel like you were witnessing a real-life time-lapse, only missing the Discovery Channel soundtrack. Their formula is simple. They don't build buildings, they assemble them. Every wall panel, steel frame, and staircase is pre-manufactured in a factory, packed, shipped, and fitted together on-site like pieces of a massive jigsaw puzzle. No overflowing concrete, no shouting foremen, no clouds of dust, just the crisp, metallic click of steel locking perfectly into place. And if anyone still thinks China's construction speed stories are exaggerated, they need only remember 2020 when the world froze under the COVID-19 pandemic. While many nations were still debating whether to extend the state of emergency, in Wuhan, China had already built a 1,000-bed hospital in just 10 days. Not a row of makeshift tents, but a fully equipped medical complex, complete with central oxygen lines, electricity, plumbing, intranet, surveillance systems, negative pressure isolation rooms, and separate intensive care wards. More than 7,000 workers, engineers, and volunteers worked in 3 continuous shifts around the clock, coordinated through a national command system where a 30-second phone call could replace an entire month of paperwork. Last night, the workers worked all through the night, and another shift of workers started to work at 2 a.m. While Western nations could spend 10 days just finalizing bids and signing contracts, in China, 10 days were enough to dig the foundation, assemble the steel frame, connect utilities, test equipment, and admit the first patients. Each hospital module was prefabricated in a factory, transported by truck to the site, and snapped together like giant Lego blocks. Construction teams were coordinated via satellite, monitored through a network of surveillance cameras, and managed by real-time progress tracking software that kept every step perfectly synchronized. Well, I think it's remarkable that China can put together any sort of facility in such a short period of time. They did this in 2003 during SARS. They built a 1,000-bed facility in 6 or 7 days, and there looked like 2 were actually doing it again. According to the China State Construction Engineering Corporation, CSCEC, the entire design-build handover process lasted only 240 continuous hours. Every 5 minutes, a new module was placed precisely into position, as if the whole structure were being assembled to the heartbeat of a nation racing against a virus. The Huashen Hospital officially opened on February 2, 2020, and just 12 hours later, the first patients were admitted. From there, the Speed Hospital multiplied, Leishenshan, followed by dozens of field hospitals across China within weeks, all built on the same formula, designing and constructing simultaneously and eliminating the very concept of waiting. Some say machines are tools of humans, but in China, it sometimes seems that humans have become the tools that keep machines running smoothly. They're not just building infrastructure, they're redefining the limits of what's possible. Not just boring tunnels, raising bridges, or laying tracks, but drilling into the core of the word impossible. While the West continues to write reports on the social impacts of industrialization, China writes its reports in concrete, steel, and real time. If you found this video interesting, don't forget to like, subscribe, and turn on notifications, because there are still many stories coming up that can not only bend metal, but also physics.